Hello, and thank you to Gabriel Menotti from the Universidade Federal dello Santo Spirito in Brazil for a really interesting talk, and before him, Dean Irvine from Dalhousie in Canada, and our colleagues in Montreal. So now we have a panel here live at the University of Alberta. As I mentioned before, my name is Jeffrey Rockwell. I'm going to be introducing my colleagues here who are going to talk briefly, and then we have a series of questions, and hopefully they will take over and ask their own questions. So I'm going to start by introducing Eleni Strulia, immediately to my left, a professor of computing science. She leads the Service Systems Research Group, a multidisciplinary team that focuses on the technical and socioeconomic concerns around building software systems for the purpose of service delivery. And she's also the NSERC I-Corps Industrial Chair on Service Systems Management.
Thank you, Geoffrey. Thank you for inviting me. It is a great opportunity to be part of this panel. It's a great venue to discuss from so many different perspectives this very interesting, for me, technological phenomenon. So I would like to start with a little bit of a short history of how we ended up here. So in the olden days, machines were expensive and centralized and owned by big corporations. So the process of data production was very limited to the entities who could own these machines. So there might have been big data because as soon as the software went into the workplace, we started recording many aspects of the workflows, but they were not that generally available. And then the pendulum shifted and we had powerful personal machines, and then the data was limited in these small little clouds that were owned by individuals. So again, we didn't have the phenomenon of aggregation. What has happened now is that we have many, many different computing devices. So I'm wearing a Fitbit, it collects some data about my activity or lack thereof. We have Roombas in our homes, we have mobile devices that know which applications we're using when and at what point in time. We have social platforms that know about us as individuals, our pictures, our social networks. We have health systems that collect information about our health, lifestyle, diagnosis. There's a huge variety of places where software exists and records data. And this variety of data has created the problem of where do we store it. And the major enabler in my field was this notion that we can have distributed storage that looks like a big fat computer someplace on the cloud. So now this is a ginormous opportunity, and I'm using a technical term here, I apologize. So what can we do with this stuff? First of all, it's varied. Some pieces of data come from machines, and they're very systematic and very regular and easy to understand and analyze. Yet others are text that is produced by, I don't know, you're working with a court system, is something that is mildly structured but much more challenging to analyze and extract knowledge from. And we have Watson, which was a recent success story in analyzing text that is unstructured. We have the more general Internet of Things, so we have many, many different devices that are organized in small little networks, and if we understand what events they emit, we can have a wealth of information about what people do where, and we can control the environment in order to make it more pleasant, more safe, more inhabitable. And for sure, we have a wealth of information in social platforms that can allow us to give recommendations on what people should do. So these are fascinating problems for my discipline and present huge challenges because now we're coming up with different programming models. We have to realize that this variety and the size of data is actually changing the way we develop programs. So you asked us to think about what we're doing in research and teaching. We have to actually come up with different systematic pieces of knowledge for how to deal with this data. We have different architectures. The classic RISC architecture is not what we're talking about. So sometimes we're developing algorithms on GPUs for doing signal processing. Sometimes we're developing Hadoop-based algorithms on big storage systems in order to do parallel processing of text. Some of the work that you have been doing is related to that. So we are developing new programming models, and we are developing new software architectures. It used to be the case that you knew that you're developing for a PC, and you had a few languages that you could deal with. Now we have a variety of mobile applications. There are different platforms. They evolve very fast, so change is something that we have to deal with. The volume with which the data increases is something that has us thinking about how to change the architecture at runtime to make it elastic, to make it flexible, to allow it to accommodate new clients and new types of data. And of course, data mining is the biggest challenge of all, because the objective of actually having big data is to be able to use it to support decision making. Analyzing data simply for understanding what people do, simply for understanding whether the infrastructure is in good health, is valuable, but certainly it would be missing the boat if we do not think what can we change in the way we act, in the way we solve problems, in the way we deal with the environment. And if we don't take the opportunity of actually learning from the evidence that the data represents. So from that perspective, the types of skills that we need to consider and give to our students and actually to our teams, because I don't think any individual can have these competencies. We have to think about teams that work together. We need statistics, we need document analysis, and document goes all the way from text to natural language to actually semantic extraction. We need complex media analysis from images to sound to video to understanding the semantics of the signal in terms of scenes. We need machine learning to actually recognize patterns in the collections of the data that we're managing. We need semantic web technologies. This whole information it will be much more valuable if we actually could cross-reference it and understand that evidence collected from the infrastructure relates to the social network activities, relates to the mobile applications records. And of course, we need software engineering, which is my own personal area of expertise and interest, because the types of software that we'll be building will be very different. We'll have many different components that can be synthesized in different ways and flexible at runtime. But the thing that I want to emphasize is that there's no individual that will have these skills. Some will come from math, some will come from computing. The problems and the understanding of the methodologies come from the domain experts, whether it is humanities, whether it is health. So we need to have the ability to train our students to become contributors to well-running teams. And that's something that's a very interesting problem that I'm sure all of us have thought about, because if we have worked in teams. So the final thing that you want us to think about is privacy. And I want to note that in my world, we used to deal with privacy and security with two technical contributions. One is you encrypt the data. Data does not fly on the wire or does not get stored without being encrypted. So we had good algorithms for encryption, and that was that. That's good, but not good enough anymore for two reasons. First, we have many more powerful computing machines that can spend time decrypting things and breaking passwords. But more importantly, this is such a small piece of the puzzle. Even encrypted data can be accessible to the people who have access to administering the machines, and there is plenty of opportunity for people with authority accessing data they shouldn't. So what we need to do, we need a more interesting socio-legal framework to catch up with the privacy concerns. And the first issue is to move the responsibility for properly accessing data from individuals to the organizations that maintain the data. If anybody has read any end user's license agreement and understood it, hats off to you. I have tried, and it used to be the case that the Gmail was, 3 pages, and now it's, 15. I don't keep track anymore. They change frequently, nobody understands them, and to pretend that the people make choices in any informed capacity is just lying. So we have to make sure that the organizations explain how they manage the data. And it has to be in enforceable language that the legal framework is aware of and can enforce and punish if the rules are not followed. And the second big problem is anonymization. We need the data to be analyzed, otherwise we'll not provide any services. So to sit down and say privacy, no, you cannot access the data, would be naive and would be missing the boat of the opportunity that we have. Having said that, we cannot simply erase the names and put numbers. That's not good enough. We need to have de-identification processes, and that's a huge technical problem that is not solved and is continuously being discussed right now in the circles where I exist. But basically the problem is that as the algorithms for data mining improve, the problem of making individuals anonymous in this cross-reference set of data is becoming more and more challenging. And we have to be explicit about the objective being de-identification and not simple anonymization. And finally, we have to know when to kill the data. Keeping data forever and ever is not necessary. It can fall prey to fraud. It can, actually it's not useful after some time. So we have to basically get out of the hoarding habit that I see, as in more data is better forever and ever, because basically it is an inherent danger when we maintain all this information even though we don't use it. So proper procedures for eliminating data properly must be into place. So these are my notes based on your questions, and thank you for helping with the structure of this panel.
Great.
I would be happy to give it.
Thank you. So now I'd like to introduce Ray Patterson. He's an Alberta School of Business Fellow in Management Information Systems. He's a member of the Accounting and Management Information Systems faculty here at the University of Alberta. He conducts research in the fields of healthcare, information systems, operations management, and service science. He's published extensively in journals like Information Systems Research, Operations Research, and many others. So over to you, Ray.
Thank you. Well, the topic of big data is almost too much to limit to just an hour. And I have a few slides, but is there a way to flick through that? Or I see they've come up
back there. Will
okay.
You just tell them when you want them to advance?
So if we can go to the second slide, thank you. So we have a tremendous amount of data, as Eleni mentioned, and the challenge is analyzing it efficiently and effectively. And one of the problems is that new tools and techniques are required to process this vast amounts of data that we've never really had this opportunity before. So if we could go to the next slide, please. So what could we possibly learn from big data? One is insights to old questions, things that we've wished we could answer before, but now we maybe have insights. Eleni mentioned her Fitbit, and I also am tethered to the Fitbit device, and it's answered a lot of questions for me. And when I tie this to my own personal health, it allows me to take control personally, but it also allows other people to see all of my activities. And when I tie that in with my diet tracking tool, someone can see all the exercise I do, all the things I eat, when I eat them, what the pattern is, or at least when I report it to myself, and then they can tie that in with my behavior, with the results. And that's, from a business point of view, data like that is an incredible marketing tool. I mean, we would love to have that kind of data. Most organizations that would deal with that. So the next area is data can inform new questions. So one of our professors, Michele Samarani, is actually using data and data mining to try to discover what the questions should really be. So you have the data, but you didn't know what questions that you were supposed to ask. And that's a big area that's coming up. And so we're actually getting smarter because the questions are being driven by the data itself. And then that leads us to boundary expansion. So it's not just about this lower cost to acquire data, but this efficient frontier or the boundary of our possible. has shifted outward. So what I like to say is that the possible is changing. So if we could go to the next slide, please. Thank you. So there are a plethora of new business types of business data. I just mentioned a few here. They're all over the place, and it's permeating every single aspect of business. And a couple of the things that I think are driving the big data transformations in the last couple of years are the Internet of Things that you mentioned, and fog computing, which you mentioned, with Fitbit and whatnot. And of course, those are massive influences. But things like mobile phone tracking, that is going to become a big player. And of course, Apple and Google are both in that space, and other people want to be in that space too. But when companies are in that space, they don't do it necessarily by themselves. They partner with many, many, many other companies to provide a comprehensive set of services to you when you come to their website. And we've have one study where we've shown that businesses are partnering with many, many, many other organizations to provide you with that service, or to advertise to you, or to sell your data, or there are many reasons why they might join. If we could go to the next slide, please. Thank you. So the impacts are transformational, and whether it be privacy and security, or new discoveries of behavior and even human disease, and collecting and combining the data from different sources has a lot of impact. So in the business side, we actually are seeing new business models. And I saw a story yesterday by somebody claiming that the MBA programs are a thing of the past. And well, I don't think that's true, but I do think that there are new emerging business models. And one of the drivers of those new business models is the new realities of zero marginal cost products. So you have an app, to deliver that app to the next person is almost zero. It's amazing how cheap it is. And so you scale, and all the things that we used to think of as constraints are no longer constraining us. So when it comes to scale, when it comes to what would you do if, for example, if you thought of an automobile, and if to replicate the next automobile, it was truly zero marginal cost, it would change everything. And it would change pricing structures, it would change contract relationships, and those are all the things that we're looking at in the business school. And then also privacy and security, big issues. And so if we could go to the last slide. And so we've got, second to last slide, we have very different analytic methods. These are typically categorized into three areas: descriptive, predictive, and descriptive, predictive, and prescriptive analytics. And if we could go to the next slide, the cross-functional skills. As Eleni mentioned, I think that people are looking for the unicorn, and they can't find unicorns.
A team.
Mm-hmm.
And a team is
That's why it has to be a team. You're right.
But my advice to my best students is maybe you can't be a unicorn, but try to be as close to a unicorn as you can be. And then you can manage on these teams when you have computer scientists and epidemiologists and everybody else from all walks of life combining. So.
Thank you. I've just actually been reading about the black swan effect, and I didn't realize that a black swan was like a unicorn. It was considered for a long time an imaginary
Animal.
bird until they saw them in Australia. So at this point, we're going to pass it over to Jennifer Chesney. She is the Associate Vice President of University Digital Strategy here at the University of Alberta. This is the first such unit at a Canadian university whose research and applied focus, with a research and applied focus on the convergence of the web, digital learning, mobile, and social media in a student-centered environment. She's also the founder of the University of Alberta not-for-profit spin-off company Leia, where she leads the growth and strategic business development of innovative digital learning experiences for the academy and industry. So over to you, Jennifer.
Thanks, and I'm really excited to be here. I'm really excited about all the people online. Shouts out, because this is all about your participation, and I hope you guys are going to send us lots of cool tweets, questions, things you disagree with. Let's get that going. That'll be really exciting. So I have a canned presentation that you'll see at some point later in the conference, and that really kind of overlays everything that I'll sort of just touch on here. But one of the first things I wanted to share is, so I'm not a professor, and I don't play one on TV. I actually come from the world of digital product development and digital marketing, and have been applying that in what I do at the university for 5 years now. And in doing that, when I look at big data, and the team that I've built that looks at big data, we are the folks on the other end of it. So we don't build it, but we examine it, and we both build predictive models off of it and prescriptive models off of it to Ray's point about what you're doing analytically with the data. So when Jeffrey asked, hey, what's your definition of big data? I actually do what I do with much of my team at work and in my research, which is I'm going to mash up some stuff. So one of the definitions of data that I really liked came from Steven Weber, who's at UC Berkeley School of Information and Department of Political Science. So he had a very long definition, but a piece of it that I really liked was big data for me is data at a scale and scope that changes in some fundamental way, not just at the margin, the range of solutions that can be considered when people and organizations face a complex problem. So I really liked his piece of the puzzle, and then I mashed that up with startup company Sum. It's called Sum Company. Drew Conway. He was the head of data at Project Florida, also more on kind of the business analytics side as I'm from. And he had, in part of his definition, he said how humanity interacts with the world and each other at large scale. And so in the presentation that you'll see later, I will be talking specifically about case studies about how my team really understands on a deep fundamental level the abilities of the Google search algorithm and how we use that to amplify reputation, reach, and return on investment for the University of Alberta, specifically taking plain names that there are millions of indexed hits on across the web and getting that to the top of the Google search result page. Because in what I do, that's kind of the name of the game, is how do I get all of the professors and the work that they're doing here to the top of awareness in the digital virtual space, which is more about organic search engine traffic. Every year we see that go up and up and up. We've hit our U Alberta domain, we've got close to 50% of the traffic coming to us is from organic search, so pre-qualified search coming into the domain. Then we have someone landing and going through the complex hierarchy of finding that special Arctic Circumpolar Institute that's doing that one very cool thing, right? They're coming out and in. And the second case study you'll see me talk about that relates to the startup that we're doing with the University of Alberta, which is not-for-profit in the educational space called onleia.org, is around what we've done with massive open online courses at the University of Alberta. Unlike the American press, which made a big fuss about Arizona State University's section of courses that they're now doing 4-credit MOOC 2-credit kind of model and saying that was the first with edX and whatnot. Well, guess what? No. University of Alberta, up here in Canada, Edmonton, did that first here. Now, we did it with one course, but we developed MOOCs here at the University of Alberta with a very strict pedagogical rigor around them and an interactive production quality that ensures that this does qualify as electives for credit on campus. We've had about 5% in just our first 16 months of our own student body take these MOOCs for credit. And then we've had over 78,000 people around the world taking them. So this is also giving us the ability to have an even richer set of data and data points that we can then mine for predictive and prescriptive analytics as it relates to the market research area that I'm in. So I'll stop there.
Okay, thank you. And as Jennifer said, we have a carefully scripted and pre-recorded presentation that we will touch on later. And if you see us working on the laptops, it's because we're tweeting. And so as Jennifer said, tweet back. In fact, somebody from the Wild Rose Party just tweeted the U of A World. So
Right on, Wild Rose.
Hello.
And everyone else.
Hello there. And so now I'd like to introduce Christoph Schindler. Christoph is a visiting researcher from the Information Center for Education at the German Institute for International Educational Research, where he is a research associate. He has a background in anthropology, social sciences, and information sciences with a focus on science and technology studies. He worked during his studies as a web developer and programmer at a startup, the Institute for New Media in Frankfurt, and an online version of the German national newspaper, FAZ. And you might tell us a little bit about that. And he is now involved in the realization of infrastructure for educational research and practice and coordinates the new research area e-humanities at the Information Center for Education. So thank you for coming all this way for this panel.
Thanks for the great introduction. Thanks as well for the possibility to really participate at this great distributed conference around the world, which I can really attend next time local from Germany, which is really a nice future for this conference. I would like to give a short overview about the situation in education by sketching up the situation in educational research and the situation in educational information, bringing over there one example of each area. Thereby I want to try to use the term scale to, on one side show the new capacities which are over there, with this big amount of data, which are really great as well in these two areas, but as well there are as well a scaling of boundaries with that, which need to be taken into account with that. So in the area of information, where I'm working at, we have a great possibility over there really to enhance the existing services, but as well to create new ones. One example is what we have over there is the German Educational Index, which is a reference library with about 800,000 reference items inside, which has a broad range of possibilities to offer services. Next to retrieval, there are a range of possibilities to monitor the educational research community over there, but as well to monitor trends inside of the educational research area, to bring these out to the public and show what is happening in this respect. Scaling this data with, for example, data from the semantic web is extending this broad range of possibilities which are over there. Recently, this is discussed with the topic Altmetrics, where you can really then follow the outcomes of research like publications as well in the social sphere of the semantic web. You can have a look what kind of activities are around, how is this topic or this kind of publication discussed over there. What comes with this is as well that on the level of the literature database, there has to be already a lot of boundary work to bring together different standards, the different kind of actors in the field who are creating this kind of data. And this is a quite hard work to do to offer this kind of services. If you're scaling up the data into the semantic or the social web, you have to put in much more actors and in much more systems really to adjust the kind of data level over there. And this is hard work to be done over there. Offers a lot of possibilities. There are some boundaries over there. It's really the area when there are black boxes, if you come to algorithm, if you come to scope of data, which are sometimes hidden in the different systems. In another example, which I would like to give, is in the area of education. You mentioned already the new possibilities using the web as a technical platform for learning. So the situation in education changed over there as well concerning the new amount of data which is possible to get over there. So new topics arise like learning analytics to dig really deep into this kind of interaction, which are now possible to be tracked. Imagine you had before just paper-based test items where you just could rely on inscriptions on the paper. Now you are tracking really the whole learning process, the interaction with the material, which really brings up a new amount of data to be analyzed over there. As well over there are a lot of possibilities. You can really have the chance to adjust learning environments, items over there to the individual needs and skills of the learners over there. But as well, you have a boundary concerning data protection, we already heard. Coming from the research background, there's as well the difficulty if the systems are closed, the validation of the data is as well really hard to be realized over there. This is a small introduction to the area of education where these kinds of areas are really we are dealing with.
Thank you. So our last speaker is Leia Phillips. She is an epidemiologist and an adjunct professor at the U of A. Her interests in big data are focused on understanding the utility of big data in healthcare. She's particularly interested in feasibility, ethics, and scientific challenges when using big data. She sits as a guest member on the Executive Committee of the International Joint Policy Committee for the Societies of Epidemiology. I hope I'm getting this right. And is the co-chair of their working group on conflict of interest and disclosure. The privatization of healthcare data and the potential for big data in the health systems around the world is an important topic to epidemiologists and the philosophers of the scientific method. And I should mention that one could argue that the epidemiologists were doing big data long before the rest of us sort of woke up to it. And so, over to you.
Thank you. No, and I appreciate being here. Thank you, and nice to meet all of you as well. I think that's one thing I wanted to touch on is epidemiology has a reputation of in some ways good and bad in terms of the way we look at health and how we understand the distributions of and determinants of health around the world, and we try to link that information to look at patterns in healthcare and in health states of people. So in terms of looking at the history of epidemiology, we can go back to Hippocrates looking at multimodal different ways of understanding people and how they interact with their environment to cause health states. And then we can fast forward 1,000 years and look at the mapping of disease across the cholera epidemic in London. And that's where we kind of start talking about big data at that point, because the history of epidemiology in that way was to map out situations where disease was present and then look at information from those communities and decide how the patterns look to be able to identify where the disease source is. So in London, the cholera epidemic was discovered or was managed because of information flowing in from spatial data, basically. So, and now fast forward into the future and where epidemiology sits with big data and where healthcare systems sit with big data is as much as we would like to be like, oh, we may be the father of big data, but we may not be the end of it, that's for sure. So we face challenges in terms of big data, and some of the things that we've all talked about in this table today is really has identified those challenges even more for me. For instance, basically, if we try to use big data in healthcare, as much as we would really like to, because there is such great opportunity to link our healthcare information to our social information, to our buying information, to different parts of our personal healthcare, we are still at the pinnacle of trying to understand how to do that. So even here in Alberta, we have great aspirations to link data throughout all the many different information systems that we have. So a lot of times in healthcare, we use what are called patient registries that collect information on a disease process. So if you have an injury, you may be a trauma, may be put into a registry, that information is there. Your healthcare data is stored in a different information information database. Your information, if you have rehab, is stored in a different information database. And if you have information about in the private sector, that is stored in a different database. And so one of the things that we would love to do, and I think this is kind of the dream of all epidemiologists because we are obsessed with data, is to find a way to be able to link all that information in a way that can create one patient record for one and for one patient at one time, and be able to kind of simultaneously in real time go into that record and understand it and look at it. However, we are not at that state yet. We still are looking for those solutions. And for instance, when we talk about big data in the 3V kind of way, the volume of information is huge, and the opportunity is there. The velocity of our information capture, though, is very, very slow. So in terms of if you were to visit a hospital today, the information that I could pull on you would not be able to be, for one incident, would take me about 2 years to get back into my data. Wow. So because of the time it takes for the information to be collected, we still collect paper records. We need to use, we don't have semantic programming to read handwritten notes or to understand anything that isn't calculated and categorized. And we don't have that kind of ability yet to do that. And so we're working on it. I think in all systems around the world, we're no different here in Alberta than we are around the world in this kind of challenge. And in terms of variety, we have so many different ways of having information that in order to make big data a possibility for us, we have to understand the variety of information that we have. So, and as I said, we are challenged by the fact that our information is siloed. It's hard to access. It's unstructured. Yet at the same time, we can do these things in smaller sets. And when we do use big data in terms of large clinical data sets that exist, the problem is that it is very narrow. So there isn't a lot of information that we can gather out of that. So we look at that in terms of trying to understand the whole picture, and yet we are missing 99% of that picture. So we can't make good decisions for healthcare unless we have that information. So of course that brings challenges in every way, and so thinking about what we could add to that information to make it broader would be personal healthcare devices. If you could add that into your own record, it would be fantastic. Healthcare surveillance systems in public health are very, very good at understanding determinants of diseases and patterns of diseases across geographical areas. However, that's not linked to maybe your personal healthcare information. So if we wanted to know what areas of the city may have incidences of certain types of diseases or cancers or things like that across the province, across the country, we can get that, but we don't know anything else about that. We just know that there's a pocket there. So we would have to dig deeper in our way to be able to understand the other determinants of that situation. So we need to improve that quality. However, again, this always comes back to the governance of this information, the privacy of this information. Healthcare is in the different domain than a lot of the other things that even are of all of your interest, because people are so I guess in some ways, I don't want to use the word paranoid, but protective of these of private information. And one of the things that we don't really quite understand enough is the governance of that data. Who owns it? Who is responsible for it? From what I understand and what we are kind of understood to believe is that once information is collected in these registries that exist, that data no longer belongs to the patient. It belongs to the person that governs that registry, which is usually a physician. And the physician then has an obligation to keep your information safe. So he's bound, or he or she is bound by that. Therefore, how do we feel about them just releasing information into a cloud to be able to make better healthcare decisions? Everyone wants to do that, but the governance around doing that isn't yet possible, or hasn't yet been structured out. So that's one of our kind of concerns. And in terms of the work with our Joint Policy Committee on Conflict of Interest, one of the reasons why big data is important for us is because in order to do all of these great things that we would love to do with healthcare data, we don't have that capability. We don't have that team. We don't have the unicorn to make it happen. So we have to partner with industries and with other universities and technical skilled people to be able to make these things happen within our healthcare system. And we get very paranoid, again, use the word paranoia, about corporate kind of interest within healthcare because of things that we've seen in the past, for our past mistakes of using private research dollars or influences of big everything, how we we're challenged with that. So as our conflict of interest group looks at those challenges, we're trying to understand how we would govern ourselves around using corporate corporations to help us make this happen. So we would love to partner with Google or somebody like that, but then we face the challenges that would face everything. So what does that mean for us in terms of our research, our bias, our information? So, and the last thing I think I just wanted to talk about too is a little bit around the philosophy of science and using big data in terms of epidemiology. We are, I guess that we're kind of tried and true in our scientific method, and so we like to be able to hypothesize and test and look at associations and look at causative effects of disease. And so when we look at big data like that and we talk about mining and fishing for information, that goes against our own understanding of science. And so we have to think about how that philosophy of science will change, and how are we okay with that? Is that the way of the world now? And we just need to get over our sense of this is incorrect science. And I think this is a fascinating topic to look at in the next 10, 20 years, because it is going to change, and I'm not stuck to that, but I think that there are a lot of people who will be, and how do we deal with those challenges? That's how epidemiologists, I think, would think of this, and don't speak for our whole group, but on our international committee, that's what we're tackling.
Thank you very much. So you've all answered the questions I had prepared. So I'm stuck now having to quickly come up with new questions. So meeting adjourned.
And done.
I do have actually variants on it, but I'd like you all to feel free to ask questions of each other now that you've been introduced and heard from each other. I'm going to start off with a question about our responsibilities as teachers, as researchers, as administrators. Where this is happening now, whether it's hype or not, we need to make sure that the University of Alberta and other universities are responding in an appropriate way. So and to be honest, we have big data. There are 35,000 students here. We have a lot of information. Yep. And if you put in all the information we have about past students, we have lots of research projects, all with their own information. We have the library's Education and Research Archive that's digitizing material. We are custodians and creators of a lot of data ourselves, and data about youth, about ourselves, about past, all sorts of things. So what do you think we should be doing? What should we do in the short term? What should we do in the long term? What are our responsibilities? Does anyone want to leap in first?
I actually want to make a comment on Leia's last point on the scientific framework. So we used to have a scientific theory formation process. We had a hypothesis. We ran a good experiment. We collect a bunch of data. We know it worked or not. And
15-minute warning. Sorry about that.
Okay. Okay, I have 15 minutes. So
Not just you.
that served us well, but now we have all this data and everybody feels free to gluttonously go and dig for anything and everything. And that's bad for two ways. First, it's wrong because the data that we have does not have associated metadata on how it was collected. Mm-hmm. So you mentioned about comparing students. Now the students of today and the students of 30 years ago have nothing to do with each other, and analyzing them together is probably wrong. Mm-hmm. I do not actually know if that's the case, but that's something that we should be thinking about. Just because we have the data, digging through it will give us correlations like the stuff that you see on the web, that cheese corresponds to, big shoe sizes. There are correlations that's completely useless, completely meaningless. This is not research. The second problem is the issue of actually what do we need to analyze in order to gain knowledge, which we should. There are many examples of cases where you can take lots of examples, but smaller slices. You do not need the whole patient record. It would be nice, it would be nice only because we are lazy. You have everything, you run all the correlations, and we get some information, then we can use our judgment to figure out if that means something or not. However, if we did our job properly, we would get different slices of the types of things that we want to analyze, and therefore would be de-identifying the data. So if I only know my blood pressure and whether I ate tomatoes or not, that would be potentially an experiment, and it would be dangerous to no one because they wouldn't know anything about my weight and other things that I prefer to keep to myself. So we have to be more thorough as researchers on developing a new framework for conducting studies on this big data in order to make it useful, but not simply dig through everything that we can get our hands on, just because there are big databases that we build.
If I could add to what Eleni's saying, one of the things when we look at educational research and humanities research in general has been these statistically significant sample size is far less than what myself coming from financial services for years would say, no, this is statistically significant sample size. And you can't just, when you look at, for instance, the data of, if you take 78,000 people in 16 months who have all interacted with your educational material, and you know probably close to 1 billion data points about that, but you don't know who they are, actually, that's completely randomized, unless they tell you. So one of the ways we've been working on it in MOOC research is using a very old-fashioned concept, which is the survey. And the survey out there, if they choose to answer it. And what's amazing about that, and I encourage anyone at any university who's listening to this, where their university is also doing MOOCs, to go talk to the people who are actually doing the MOOCs. Because what you're going to be able to see is you've got this wealth of folks who are eager to actually answer your surveys. They're interested in that. So you can go from a sample set of 10 in educational research, or you can go from a sample set maybe of 150 to 200 in longitudinal studies to we were seeing an average of N equals 6,400. And sometimes N was as big as 15,000 of what they were answering and how and what they chose to answer. So it is a way for humanities researchers to, as appropriate and within the guidelines of their ethics policies and their privacy policies in their countries or at their institution, to start to actively engage the learners who are there participating in their educational derivative products and giving them insight because they're willing to do so. And we've been finding tremendous advantage, I'll just say it that way, from the business side of the university to really understanding that and having them help us guide some of our strategic choices that we're making as it pertains to these derivative educational products. So I think using something as old-fashioned as the survey in an online format and gathering that and continuing to keep it randomized, and of course we can have all the bells and whistles about making sure that, I'm not gaming the system and putting in 50 surveys just from myself. All that can be done with technological constructs that are already built. You're suddenly opening up yourself to a whole wealth of folks that you can talk about. So when we talk about disease management, right? Those people who might actually choose to answer the question, why, yes, I do have asthma and I've been, self-medicating my entire life. And of that 78,000, you might have a really relevant group of people who you can now then, should they choose to participate with you, continue to ask questions that may be relevant to your research area. So I really want to encourage all the humanities researchers out there to think about that new potential sample set for them if their universities are in these types of educational products and services.
Is it possible to follow up?
Yeah, please do.
So I just want to caution researchers in this area. This is a fantastic opportunity, and a paper that we did about a year or so ago that we're very proud of because it won an award highlighted the dangers of not being very careful with this big data. So out of using the big data, we were able to show that there are a large number of respondents to surveys that don't engage their brains when they fill out the surveys.
Oh, yeah. There's a science to survey writing, that's for sure.
Yeah.
Yes, there is.
And what we showed in the health, this was in healthcare, was that up to 95% of the survey respondents really can't be relied upon to tell you about the details of their experience. They can tell you what their overall satisfaction is, and the factors are the same whether they are or not engaged, but their responses to those questions give you a different picture of the importance of the different factors. And so just a cautionary tale, as we enter big data, there are going to be many more cautionary tales that come out about the use of all of it.
Would you take it the next step and say, we now have a responsibility to teach what I'm going to call digital citizenry, given that anyone in Canada or North America, Europe, is probably having their information aggregated and used and so on like that. We need to be teaching citizens to understand at some fundamental level, not understand the algorithms in general, but to understand how to be careful with the information, what might be done with it, and to be aware of how these inferences, when somebody tells you this is a data-driven inference, doesn't mean it's necessarily true, and there are ways to critique it.
Absolutely. And so a question that I would pose to the panel is, what are the impacts on privacy and security of all this? And here's a fundamental question. Is privacy dead?
No, I don't think privacy is dead. I think that, again, speaking from my research area, I actually don't know who any of those humans are. All I know is what they're doing. And it's the patterns of what they're doing that I'm learning from. But I don't know who they are. Now, I have course data, but that's different, and the survey data, but I don't ask them things like, who are you at a granular or molecular level, because I'm interested in the macro view of what's going on with what they're doing. So I think privacy could be dead when you get to the point of your Fitbit and where that data is going, because that's you. And that's you tied to your credit score, and that's you tied to so many aspects that we could build a whole profile about you, right? But in the aggregate, on the macro, I'd hate to see us lose the ability to do macro research because of the privacy around the individual. I do absolutely think that we need to respect the privacy of the individual and the ability to opt out and not buy a Fitbit and not wear Fitbit and not want to have that data going to whomever and used in whatever way. But I just don't want to lose the macro, because we're learning so much about the way people are working across the globe beyond the constructs of nation-state borders and these socioeconomic boxes we put everybody in. They're teaching us things beyond that we haven't ever considered before. And I just hate to see that go away as everybody shuts down into personal privacy.
One of the things, and it's a fascinating conversation, because in healthcare, that is the crux of our dilemma. We have macro data in public health, and yet, so we try to look at it from the patient's perspective, the provider, and then the systems that make our data. And so we would love to have all of those levels of data condensed into one record, right? But I don't think is relevant. I think we need this macro data. We don't need the small data. We don't need the deep dive data on everybody, so we can use samples from that. However, at the systems level and at the care level, at the clinician level, they would like to have that information. So they want to be able to, kind of pull up your identity in their registry and be able to see that you went to this physician for this and that for that, and you are on this medication. At this point in time, we cannot do that. I cannot go and I see my physician right now and be able to see anything about myself. It's not there. It's not connected. So I can go to one doctor in the morning and another one in the afternoon. I can go to an ER, and I can get prescriptions from all of them and go to a 3 different pharmacies, and none of that information is linked up. So we have serious issues with health and with dangers in that area. We sure would like to be able to.
But if we look at your Google searches, we can probably figure it
Yeah,
out.
but that's exactly it, is that we can, with other sources of information, I can get, kind of a profile on somebody, and it could answer questions for me. And so, is it okay to put those things together if we say it's okay, if we give permission to do that? There is actually a group of patients in the United States that have put together a patient's bill of rights in terms of their data, and have looked at, this is what we feel is okay, and they kind of encourage patients to use this when they come into hospitals. They're trying to get it kind of as, kind of a hospital policy for people. And then there's also websites that you can go onto and put your private information in and be able to look at other patients that are just like you. So Patients Like Me is one of the websites where you can just go in but I tested that website, and unfortunately it has poor reliability in terms of the selection bias that's in it. So
I have 2 comments on this issue. The first one is, goes back to my anonymization. When you're analyzing a group of people, if you were able to figure out that everybody in Joe's class hated Module 3, then you have identified, you can make a statement about every single individual. So aggregation is not solving the problem. The question is that the problem? Is it really bad to say that everybody in Joe's class hated Module 3? Why are you doing that? Are you doing it to change the module? Then it would be a benefit to everybody's education to fix the module that is terrible because everybody hated it. So I don't like Ray's question, although I have to thank him for actually being an agent provocateur, because privacy is just a word. And the question is, what are the operational semantics of privacy? And I will go back to patients. I do not think that we own the right to keep our patient data private. We are getting subsidies for taking care of our health, and it is a service that the government provides, that our society provides. If we want our society to take care of the ill, then we are responsible for helping our society, learning how to take care of the ill by providing our data back. So to say that this is private data, I find it's just sort of naive and simplistic. We have to think, what are we giving up in terms of privacy and what we're gaining in terms of services that we're getting from the analytics. So we have to be much more subtle and knowledgeable on when we are discussing the issue of privacy, because I fear it's used as basically a threat to actually taking advantage of the opportunities that we could be taken advantage of. So I think your previous point of actually studying a new methodology for analyzing data, going away from the hypothesis driven, because it was just a little bit too limiting, and just being aware of what we're analyzing and for what purpose and what service we will provide, what is the value that we're getting, would allow us to think a little bit more smartly about how this thing is playing out. Privacy is not obviously a right of everybody, and it's not absolute. It has to be given up for the good of the ever.
If we're coming to the end now, so if I can sort of wrap up, because we've had a number of interesting points have been raised here, and I want to try to connect with some of the things that have been said before. I think in some of the previous panels, there's been discussion about how we're at a moment in which, in some sense, society's understanding, if to use the Rousseauian term, the sort of social contract about privacy, what the government will keep and what they will use and how they will use it, that has to change, and we have to have a conversation. So in some sense, I would answer your question by saying, and I think this follows on what you're saying, that the key is we need to have a conversation now, because the possibilities are changing, and we need to develop a new social contract. I think Snowden has done us a real favor, less so perhaps in Canada than in countries like Germany or the United States, because he has triggered a really vigorous conversation that hopefully, out of which, in a Habermasian way, will evolve a new public sense of the expectations. And that will allow us to not have to read the ULAs, because nobody reads it.
And nobody understands that.
I read the ULAs.
You read them, and I'm going to run a course on them.
My job.
I want to thank our participants. There's obviously too much to talk about. I got an email from the Irish panel that they were having an even more interesting conversation after they went off the air than when they were on the air, and I suspect we are too. But thank you all, and I think next up we have Alex Gill and colleagues from GoDH. So over to the GoDH community, and goodbye from Alberta.